Alright, Module 3, Python Introduction. In this module, we'll learn the fundamental concepts of Python and specifically take a look at the syntax for a lot of the different tools we'll use, such as loops, dictionaries, conditionals. The next video will dive into object-oriented programming and how that is implemented in Python. And then we'll use a in-class exercise to demonstrate the capabilities of object-oriented programming and how we can integrate that with ROS to create some pretty powerful nodes. So Python is an interpreted high-level general-purpose programming language. C is considered a low level. You're closer to the hardware. The C is not abstracted as much, so what you type is pretty much what is happening. Python is a lot higher level, so a lot of stuff is happening in the background. For example, if we have a variable, you do not have to typecast it, so it's dynamically typed, so you don't have to create like an integer or a string. The variable will be dynamically typed, which could have positives and negatives. So that's why C is pretty powerful for in the electrical and computer engineering realm, because we can control how much memory we take up by controlling what kind of variables are used. Python's not like that. It's a much higher level and we don't have as much control. It is white space, it uses white space indentation to create blocks. So for instance, if we had a if statement, instead of using curly brackets, we would just create an indentation. So, and that's typically a tab. The lines are not ended with a semicolon, they just end. So next line, a new line creates a new statement. And then once you decrease the indentation, this would be the end of the loop for this statement. So going back into decreasing indentation would end the block. So that's just kind of big picture Python. Let's take a look at some of the syntax. So variables and strings, like we said, is dynamically typecasted. So printing, you can print a string or you can store the string into a variable. Both of those would produce the same hello world. It does not matter if you use one quote or two quotations. I try to typically use two quotes for a string and then one quote for a character, but often can't keep that consistent anyways. You can easily concatenate things, so you can take a full name variable and store the first and last name using the plus sign, so that's a basic concatenation. And you can see here this variable 13 would be casted as or stored as an integer. So if we wanted to force that into a string, we would have to typecast that. So it's dynamically typed and we can't really control that. You could, if you wanted, store that variable as a string by using that typecast as well. So that's variables and strings, pretty straightforward, nothing too special, much easier than anything you probably did in C if you've taken Comp Sci 210 already. If you haven't taken Comp Sci 210, which you will next semester, we might be spoiling you a little bit. Alright, lists. So a list can store a number of strings, a number of integers, but they all have to be the same type. So we can see here in this bikes example, we're storing 3 different types of bikes. And then we can access those lists, which is basically an array, it's 0 indexed, and then you just use the colon, or sorry, the square brackets to access the different indices in that list. And you can use this -1 to access the last item. So if we did bikes 1, we would get red line. Bikes -1 gets us giant. And then we can iterate through lists pretty easily. So with this statement here, and we'll learn about for loops later, but basically we are saying for each of the bikes, for each bike in the list bikes, we are going to iterate through those. So it'll go through and it'll do the first bike. So the first time it'll print Trek, then it'll print red line and giant. And the print statement automatically creates a new line each time. So that would print on 3 lines. Bikes.append, not append. It adds another bike to the end of the list. So that would get you, that would add GT to the end of the list. So now you would have 4 items in that list. You can use the colon to kind of take a portion of the list. So that's basically 0 to 2, not inclusive of 2. So that would get you bikes 0 and 1. Then you can copy a whole list as well by using the colon with nothing on either side. So that's just some capabilities with lists. They're pretty useful. I like to use dictionaries a lot, especially when working with Ross in different nodes. Dictionaries allow you to do a lot of really cool stuff. So basically what a dictionary is doing is you have a key and item pair. So for example, this favnums dictionary has a key of nef and buyer, so 2 keys, and then items that are correlated with those keys 1 and 8. So if I wanted to access Colonel Neff's favorite number, you can see in this print line here, I just take the dictionary and then I take my key and I'm able to get the 1. And so that would print Neff's favorite number is 1. So we can add things to the dictionary as well by just creating a new key and adding a new item to it. We can iterate values in the dictionary as well. So for example, this first one here for name and number and favorite numbers items. So what that would do is provide me, and this should be indented. These 3 lines should be indented. So that's another little typo there. But basically, for what that would do is iterate each of those key value pairs. So that would print Neff loves 1, then it would print buyer loves 8, and then lastly it would print cadets loves 2. Okay, so that's going through and iterating through that dictionary and grabbing both the name and the key and the value. So that gives you a lot of capability to get everything out of that list. If you just want the keys, you can just do the dot keys, or if you want the numbers, you can just do the dot values. So I've used this our capstone team used this in our robotics capstone. So we had 4 different TI bots. And I wanted to, we wanted to have each of those talking over its own topic. So for our controller, we wanted each TI bot to get a new coordinate. So they each had their separate coordinate to go to, as you saw in the video. And so each of those needed its own topic. So we created a dictionary for each of these TI bots that had its own topic. that went along with it. So TI bot 0 had topic TI destination 0. TI bot 1 had a topic TI destination 1, and so on and so forth. And we were able to then iterate through those different dictionaries and create topics for each of the different robots to then pass the destination coordinates to. So that's one of the examples of how we can use a dictionary. We'll see that in the in-class exercise. We'll use a dictionary as well, but it's very helpful. All right, conditional statements, more syntax. To test if equals, not equals, and you can actually just if you can type it out as like that as well. Greater than or equal. My pen is having some issues today. Less than, and less than or equal. You can also use, so if we take it back and look at our bikes list up here, we can use this if trek in bikes. So that is a nice conditional that we can use to some of the built-in Python capabilities to look through that, iterate through that list and see if trek is in it. So that's built in. You can also write if trek not in bikes. So we can see else if surely not in bikes. And this is how we're doing how else if is in this in Python. And last would be else. You can see the format is basically the if statement, colon, then we tab, else if, colon, tab, else, colon, tab. All right, let's talk about loops. So two main loops are the while loop and for loop. There's others, but those will be the two that we'll focus on. So let's take a look first at the while loop. So basically what you're doing is while a statement is true, so while current value is less than or equal to 5, do something, and then you increment. So basically enter loop, test expression, that's a great looking diamond. Boom, diamond. If it's true, do something. Then come back and test it again. If it's false, exit the loop. Or exit loop. So that's your while loop kind of flow. And then for the for loop, so for each item and sequence. And so what we are seeing here is the example is for x in range 3. So range 3 is just the values 0, 1, sorry, it goes 0, 1, 2, and then once it hits 3, it exits. So that would be the same as saying for int I equals 0, I is less than 3, I plus plus. But the flow, check if the last item is reached. False. Do something. True. Exit. For loop. So the while loop will allow you to kind of go through something until the expression becomes true. So, you can do anything you want. So we'll see it in the isolator where we're asking the user to put an input, and while that user is putting an invalid input, we're going to keep asking them to try to enter a valid input. So that's the benefit of a while loop. It'll continue until some statement becomes true, whereas the for loop will go and allows us to go and loop a specific number of times that we can pre-coordinate. All right, functions. So a function is just a kind of, you think of it as like a puzzle piece, a piece of code that you can pre-create and then use later. So for this example, we are going to make a pizza, and a function can have parameters coming through. So topping would be the parameter, and all the function is doing is printing have a topping type of pizza. So you can see here we've put a default topping. So if I don't insert a topping, which I didn't here, it's going to have a bacon pizza. But if we do insert a parameter, we will have a pepperoni pizza. You can have multiple inputs to a function. So you can see here, we can add numbers 3 and 5. That's going to be a sum, which is going to be an integer. Obviously, it's going to be 8. And then we can just throw that function in, and it's going to return the value 9, and then we can just print that as well. So that's really high-level functions, just an example. All right, classes. We're going to go into a lot more detail with classes later. I just want to introduce kind of the syntax for a class. So typically a class will be uppercase, so you can see here, and functions will be lowercase. I like to use the underscore. Some people like to use camelback, which is something like this. That's up to you, but just make sure that the first letter is lowercase, and here it's uppercase. All right, and then this type of comment is kind of at the beginning of a class and function. So the dog class, we can initialize the dog class. So every time we create a new class, which we'll kind of talk about in a little bit more detail, we can initialize it to have a name. So this self concept is used because you can have multiple dog objects, So every time I create a new dog, so I've created dog Spot, that is an object. So my dog is Spot, it's an object, it has a name, it has the capability to sit, which is this function here, and that object, my dog, now has some functionality. So we've named my dog Spot, just like we did with the function. We can put in a name there. That actually requires a name. We could do like we did in the function and have our parameters be self name equals dog, and then if we did not provide it a name Spot, then the dog's name would just be dog, which is pretty lame, but and that object is now named, we provide that variable's name. So for our example here, it's named Spot, and so if we call sit, we know that its name is Spot, so my dog dot name, so this means Spot is a great dog. Then my dog sit, so I'm taking self.name, which is characteristic of my object, which I have named Spot, and printing Spot is sitting. So like I said, we're going to go into a lot more detail into classes, but I just wanted to show you some of the functionality. The last thing, really quick, is modules and packages. So beginning of every Python file will include this line. That's to tell when you run it, which interpreter to use and where that interpreter is. So Python 3 is stored in here on both the Raspberry Pi and most Ubuntu systems. Serial allows us to potentially, so these are different packages. So serial is a package that allows you to communicate with the serial interface on, or like USB universal serial bus. Threads, so threading is the package and thread is the module. That allows you just kind of, instead of calling it, so that gives you the thread module. And then the last kind of import idea is if you wanted to import this whole thing, but you don't have to type that out every time, you can type it as a shorter port list, and then you have that whole library, but instead of typing serial.tools.list underscore ports every time, you can just type port underscore list. So that's the basic syntax. I know it's a lot right now, but as we get to use it and we see it in the ICE, it'll start making sense. But I just wanted to provide you these little library of syntax so you can come back and look at it whenever you may need it.